Good morning, students. We will continue chapter 2, physical quantities and measurement. So already we have covered basic physical quantities like length, mass, time. So already these three basic quantities we have covered. The fourth basic quantities, which is temperature. So about the temperature today we will see. So first of all, unit of temperature. So the SI unit of temperature is Kelvin and it is denoted by K, capital K. And why it is capital K? Because as we know that whenever we write any unit symbol, if it is named after the any scientist, this is the Kelvin is the name of the scientist, and this symbol is given after his name, so it must be in a capital letter. So that's why it is in capital letter. Apart from Kelvin, the other two most commonly used units are which are that is degree Celsius and degree centigrade, right? And again you can see it is written in degree. This is the sign of degree Celsius, and this C is in capital letter. Why? Because it is a name after the scientist and his name was Andrews Celsius, right? Second unit, which is the degree Fahrenheit, again you can see it is in capital letter. The reason it is the name after the scientist, that's why it is in a capital letter. And this is the symbol to write the degree Fahrenheit. It is the name after the name of the scientist, GD Fahrenheit. So name of the scientist, GD Fahrenheit. These units and their symbols are given. This is in the table. You can see the Kelvin, as you know that the writing of the units. So if you write the full name, so you can see it is in a small letter. It starts with a small letter, but only the small, that is only the in a short form you are going to write only, so that it will be in the capital letter. If you write the full name, it will start with the small k, right? But only if you write in the short form, so only the symbols if you are writing, so in that case it must be in a capital letter. As you can see, this is the rule of writing, because these all Kelvin, Celsius and Fahrenheit, these all name after the scientist. Second one is your degree Celsius, right, or degree centigrade. Third one is your degree Fahrenheit. This is written in F. Now next we'll see about this. There is a one note is there that you have to note down. The unit Kelvin is never written in degree, like other you can see here, all are written in degree Celsius. As you can notice, did you notice it? You can see this is in a degree, this is in the degree, but this Kelvin is not written in degree. It's a simple K. So this is about that. K is not written as degree Celsius, right? Next is the ice point, freezing point of water. That ice point is called freezing point, where the water changes to the ice. At the steam point, where water started to boil completely. Now it's going to ready for the steam. And the number of degree in between the ice and boiling means from the ice to making this water of making ice to boiling. Okay, so in between there is some gaps are there. So the number of degree in between the ice point and boiling point on 3 scales as given. So as you can see, the first Kelvins, whenever if we see in terms of Kelvin, the scale of temperature is your Kelvin. So if it is in a Kelvin, so if we talk about it, means we are representing in terms of Kelvin. That's temperature we are representing in terms of Kelvin. So the ice point is 273, right, and the steam point 370. So what is the number of degrees gap in between? Means becoming the ice to the steam. So what is the gap? So gap is 100, right? For the Celsius, 0 degree to 100, so gap is again 100. But in case of Fahrenheit, this is 32. That is the ice point when it becomes the solid ice, right? That becomes water becomes the ice completely. That is 32 degree, and it's the boiling, means it started vapor. Water turns into the vapor state. This is the 212, and what is the gap? 180. So now, so from this table, what we conclude? 1 degree on 1 Celsius is equals to 1 degree on Kelvin scale, right? So the reason is that the gap is 100. The gap is same. That's why Celsius and Kelvin is equals to 1 degree on Kelvin scale. Second, 1 degree on Celsius scale is equals to 9/5 or 1.8 degree on Fahrenheit scale. So this is the relation between Celsius and Fahrenheit. So as you can see here, in between these two, Celsius and Fahrenheit, this Celsius and Fahrenheit, because the differences is there 100 and 180. So about this I will tell you about this, how does it work. It's a mathematical terms I will show you. Now next we'll see there are 100 divisions between the ice point and steam point on Celsius scale, so it is called centigrade, right? So there are, in that you will notice that there are how many gaps are there, 100. As you can see, here is the gap of 100, right? So that's why it is called centigrade scale, right? This is also called, that's why it is also called centigrade, because it is called Celsius. This Celsius is also called centigrade. The reason is the 100 division, because there are total how many divisions are there, 100 divisions, right? Now so just we see this some mathematical terms of this. So first of all, what we have seen here, we have seen it the Celsius. So we'll see the first is your Celsius, right? Second is your Fahrenheit. Okay, so now as you know that first we'll see the, this is, you can write Celsius, this is your Fahrenheit. Now first we'll see boiling point, first we'll see the ice point where it's freezes. Okay, so we will see the ice point. So what is there, 0 degree, right? And here in terms of Fahrenheit, 32 degree, as you can see here, 32 and 0, and here is 100 and 212. So there, that will write here. So now for this this is called steam stage or vapor stage. So here this is your 100 degree and this is your 212 in terms of Fahrenheit, right? So now what we'll see, we will see its changes. We'll see its changes, means we will check out its changes between these two and these two, their differences we will see. So we can write here, this is the sign of change in Fahrenheit and divided by change in Celsius. This is to use this sign is we use for the change in. So now in change in Fahrenheit, what is the change in Fahrenheit? 212 to 32, right? So that we can do 212 minus 32. 212 minus 32. And what is the change here over here? In this, as you can see, change is the 0 to 100. So now as you know that highest minus, so 0 minus 100 minus 0. So this will give you 180 and divided by 100. So this 0 0 will cancel out. So 2 times 9 times by 2, and this is your 5 times. So now what we got? 9 by 5. What is the change in 9 by 5? If it, and simply if you just multiply the cross multiplication, the F you will get F equals to 9 by 5 into C, and this 32 will be added. This is the difference. So now why it is, just I will show you, just check out. See here, this is why you used to write like that. So if we have 0, now we have the formula for this. This is the difference. Just now what is the difference we got for the Celsius? This is the difference was 100. So that's why we have written here C minus 0 by 100 equals to, this is the F Fahrenheit minus 32. These derivations are not required to you. For this you have to study in class 8-9 about this. Just for intro, just you see it, okay? Just to know about this. Basically you have to learn the formula. This derivations is not required. Only the formula is required. The formula you have to learn. So now next, this is the C minus 0. That is the C by 100 equals to, right, F minus 32 by 180. So now we can cancel out. So this will 0 0 will cancel. This is for 5 times, this is for 9 times. So now we have C by 5 equals to F minus 32 by 9, right? So now we can do the cross multiplication, right? So and we can get the F. So to from here, if you will solve this, so you will get the one formula. That is the main important thing that you have to learn. The formula is F is equals to 9 by 5 multiplied C, that is the Celsius, and whole added by 32. This is the one of the formula. This is the formula to get the answer in terms of Fahrenheit. Second formula, which is the from there, that is we will get the C is equals to Celsius equals to 5 by 9, okay, bracket start, F minus 32. So these formulas you have to note down and you have to learn. Basically you have to know about this formula to change Fahrenheit to Celsius and Celsius to Fahrenheit. Basically this formula you have to learn. Derivation is not required, just I have shown you from where this the formula come, but the important thing that you have to learn this particular formulas, right? Fahrenheit to Celsius and Celsius to Fahrenheit, how you will convert it. Understood? Now come to the topic. The next which is our next is that we'll see about the temperature is measured with some is thermometer. So the thermometer we'll see, because we need some devices how to measure the temperature. So here we'll see devices to measure temperature of an object. So temperature is measured with a thermometer. So thermometers, as you have seen, mostly you have seen it. So this is the thermometer which is used in the laboratory. Okay, so and it consists of glass capillary tube. Capillary tube means a very small tube, means there is a very narrow space in between, inside very narrow space is there, with a bulb at one end. This is called bulb, this is called bulb at one end, and the bulb is filled with mercury, and this is black portions you can see here in this is the mercury, and the long part of capillary is called stem. This is called stem, right? This capillary means the very small tube, the narrow space inside that. Okay, that is the capillary. The stem has marking minus 10 to 100. So you can see it is start from minus, it is started, as you can see here, this is start from minus 10 and it goes to the 110. The maximum is 110 and the minimum marking is minus 10 degree Celsius. And how does it work, that we'll see. So now as you have entered, the 0 mark is at the level of mercury in the capillary. Its bulb is placed in melting ice. So whenever you place it in the ice, melting ice, so what is the reading will show on that? So that will be 0 degree when it is in the ice. While 100 marks at the level of mercury capillary when it is placed in the boiling water. So when you will place in the boiling water, okay, so the temperature will be shown there in this mercury. What is the reading will be shown? The reading will be of 100 degree. And when the 0 degree when it is at inside, when it is into the ice, right? Now next type of, and you will see the space between 0 to 100 marks, the division into 100 equal division. Each division is called degree. What is this degree? So like 0, then 1, then 2, then 3, likewise it is there up to 100. So each one, this is 1 degree, 2 degree. So this divided into 100 divisions, small divisions are there. Each division is called 1 degree, right? Next part, which is our measuring the temperature of an object using laboratory thermometer. So by the laboratory thermometers, how we will use? So thus you can see the to measure the temperature of an object with the help of a laboratory thermometer. The bulb of thermometer, bulb means the starting portion of that, is kept in contact with the object. The mercury rises in the capillary. Wait some time. When the mercury does not rise further and get stabilized, means whenever you are measuring any temperature, first of all you have to just put what you have to put there, bulb of the mercury into the object. Which objects measure you have to measure the temperature of any objects. First of all you have to place the bulb inside that. Then after you have to wait for some time, because when the temperature will rise, this accordingly this mercury will rise on that capillary tube. Okay, so you will get you have to wait for some time, and you will look that when the mercury is not further rising, so that is stabilized. Look at the markup, which is at that point what is the marking of the mercury. So that will shown on the horizontal line. So that is the temperature of the particular body. So likewise here it is measured the temperature of water. So it is placed here the mercury. This is called bulb. It is placed over there. So you will see this slowly from here our this mercury level will rise, and after some time it is stopped at particular point, that is called stabilized point, and you will see whatever you have to read this reading. What is the reading over there? 30. So that is the temperature of this water, right? So next we have, that is the clinical thermometer, which is used by doctor. Many of you have seen it, even you have used even also to measure your fever. Now, so in this, doctors use a special thermometer. So it is quite different than other laboratory thermometer. It is a little different than that. So doctors, that is called clinical thermometer, for measuring the temperature of patient. So the description of clinical thermometer: a clinical thermometer has marking from 35 degree to 42. What is that? There is a marking of that 35 degree to 35 degree Celsius to 42 degree Celsius, right? It has slight band at or nick in the stem just above the bulb. This nick is called constriction. This constrictions prevents the mercury from falling back all by itself. The temperature of healthy person is 37 degree, who is very healthy, that is 37 degree. Normal persons, the normal persons, like healthy persons, what is the temperature of body? 37. This temperature is marked by red arrow. It is marked by the red arrow. So you will see this thermometer. So what are these terms, what are the used, that I will explain you. This is the same bulb, but after the bulb you will notice here this point, particular point, just you see that it is like this, right? This way it is there. This particular is called constriction. Constriction means little shrinked or narrowed, right? Band. It is a band. So why it is band? The reason is that when mercury, this mercury will raise from here, from this portion, the mercury will raise to this side. So this because of this band, that is called constriction, this mercury will not easily fall down. It will stay in this capillary tube, right? So that we can get the reading easily, or for some time it will remain there. So that's why you will see, you have seen many times doctor used to shake the thermometers before checking your temperature. The reason is that they are just sending back, or they are just getting back this mercury into the inside the bulb, because they want to clear this mercury. Because of this narrow portion or this constriction, it will not come down easily because of this. Okay, so that's why there is this kind of shapes are there, and you will have see the note, the marking is, what is the markings are there? 35 to 42 degrees Celsius, right? So clinical thermometer marked in Fahrenheit also. So that is marked in the Celsius, as well as this is marked in Fahrenheit. So in Fahrenheit 95 degree to 110 degree Fahrenheit. The red arrow indicating the temperature of healthy person at 98.6. So in terms of Fahrenheit, we ask what is the temperature of normal person? That is 98.6 degree Fahrenheit. Or in terms of, if we ask in Celsius, that is the 37 degree Celsius. This is the normal, that is the healthy person's body temperature. And you will notice that wherever this mark is either 36 or 98.6 Fahrenheit, that is marked by the red color, right? Now next, which is the measuring temperature of patient by body. So as I said that the bulb of thermometer is washed by keeping in the beaker container cold water, because the thermometers are used in a different patient. So that's why this should be cleaned. So after cleaning that, the slightly jugged means they are shaking that to bring the level of mercury into the capillary tube below 37 degree. As I said that, so they are trying to shake it, they try to jerk that, and that mercury level they try to bring below 37, because the reason is that what is the normal temperature of our body is 37. So we will try to bring down by 37 degree, below 37 degree. Then to measure the temperature of patient's body, its bulb is kept either below the tongue or under the armpit, right? So patient for about a minute, after which temperature is taken out, the reading is noted. The temperature of patient of body is above 37 is said to suffering from fever. If their temperature is more than more than 37 degrees Celsius, then we will call the patient has temperature, or in terms of Fahrenheit we will say more than 98.6 Fahrenheit. If the temperature of any patient, body's temperature of any patient, then we will say the patient has fever, right? So now next, this is the some terms that you should write in your copy and learn it. Normal temperature of human body is 37 degrees Celsius or 98.6 Fahrenheit, right? Nowadays, instead of mercury thermometers, digital thermometers are used. So we are mostly, we have seen that the thermometers, there the material is used mercury, right? But now it is replaced by the also digital thermometers, where the digital thermometers are used, where the mercuries are not used. The digitally it is measured. Then we have third one, that is the clinical thermometer cannot be used to measure temperature of boiling water, right? This is also very important point, which is used by the doctor. This thermometer we cannot use to measure the boiling of water 100 degrees Celsius. It can measure up to only 40, because in this, what is the maximum readings is given? 42 degrees Celsius. So above 42 degrees Celsius we cannot measure by this clinical thermometer, right? So now some notes are there. The physical quantities like length, mass, time and temperature, these are the four basic physical quantities. So today we have seen this temperature, already we have covered length, mass and time, are independent of each other. They are not dependent to anyone. Length is not dependent on the mass is not dependent on time is not dependent on temperature. Likewise, no one is dependent on anyone. These four basic units are independent, right? They are not related amongst themselves. Such quantities are called fundamental. So these quantities are called fundamental quantity. The reason, length, mass, time and temperature, they are not related to themselves, they are not depending on themselves. That's why it is called fundamental quantities. On other hand, area, volume, speed, etc. are the quantities which are expressed in terms of measurable fundamental quantities like length, mass, time, etc. They are called derived quantity. Means these are derived from the fundamental, right? So they are called derived quantities, because they comes from the basic quantity, fundamental quantities. So as you can see the example, area equals to length into breadth. So volume equals to length, breadth and height. Speed equals to length of path by time. So these are the derived, area, volume, these are the derived units, and right. So these are the derived units. So the next class we'll see about the measurement of area. So that we will cover in the next class. So for this class, support your homework to just read out thoroughly this chapter. Try to just see this how these markings are there, what are the minimum and maximum temperatures are there, what is the Kelvin, Celsius, Fahrenheit relations are there. Formula already I have given. This formula you have to write down in the copy and learn. These are the formulas that I have given to you. This is to convert Fahrenheit to Celsius, Celsius to Fahrenheit, right? So then after the architecture, the constructions of mercury, that you have to see which place this is called, what are the name of the part. This is the bulk, like constrictions, red arrow, capillary tube, all these terms you have to learn. These facts you have to remember it. So this go through this chapter, okay. So the next class, the last topic that we'll see, measurement of area, in the next class, okay. So thank you for today.